So this is Tech at Scale number 2. Obviously, Ritual has sponsored this. Here's my email if you would like to come do a talk, or you have venue space, or you want to tell me how bad the talk is. That's also acceptable. That's fine. I'll take feedback. This is always a disclaimer I put here, so the company I work at doesn't get pissed. So, yep, not my employer. Anything you see here is not their opinions, just mine. And this is the talk. Billions of events every day with Apache Flink. And I lied. So I redid the slides yesterday because I just hate myself, I guess. Because I wanted to combine, I haven't actually used Apache Flink at billions of events. I've actually used Samza at billions of events, but then my retrospectiveness of that was that I wouldn't use Samza ever again, and that Apache Flink is the way to go. So I am using Apache Flink for the stuff moving forward. It just doesn't happen to have billions of events, but I have had billions of events just using Samza. So some of this will be like, I'll just say, Samza is used here, but Apache Flink is what you should be using in the modern day, and here's why. But it's all still applicable. I'll walk you through all the features of Apache Flink and why I would use it and things like this. So my name's Cory. I organize these. I used to work at a company where the analytics project was like more than 3 billion incoming events. This is where I use Samza. This is where the billions of events come from. And then at present, I work at Blue Cat Networks, and it's this multi-PB data lake, and it will be using Flink. It just doesn't have multi-PB going through it yet. So, and fun fact, the first talk, someone drove 6 hours to see the event, which was actually, was like, wow, such humble brag. Like, no, I thought it was really intense. So I want to know, is anyone here to learn Flink? You just raise your hand. Does anyone want to use Flink? Are you using Flink? Is anyone actually using Flink? Okay. Wow, you're in like all the categories so far. And is anyone actually like massive scale? Like you can just raise your hand. You're from Strike, so yes. Well, yeah, that's all subjective. So it's like, I don't know, you're pushing, let's say like, you know, 1 billion events a day or more, or hundreds of TB or PBs of data. Yeah, exactly. So so obviously the first thing before we jumped into Flink, it's like, let's talk a little bit about data streams, because some people might not really know why Flink exists and why we would be using it. So just assume you have this stream of like data. It could be messages, like analytical stuff, like impressions. This is what I was most familiar with because I was building an analytics layer. So this is, you'll have many of these segments and you'll go over them. And if you came to the Pulsar talk from the first one, you know there's bounded streams, which are fixed, and unbounded, which means it basically has no fixed point in time. It'll just continue on forever. So when we talk about these data streams, we usually are talking about stuff like Kafka and Pulsar. And we have these things called stream frameworks, which are usually Flink, Spark, Samza, among others. But these are usually the kind of big ones. Aside from Samza, it's just, I put Samza because some of the stuff I'll be talking about is like, oh, this is where I was using Samza. And then you're usually trying to move the data somewhere else. So it's like either you're syncing it back to Kafka to use later, or Pulsar, or MySQL, or Elasticsearch, or some downstream kind of storage. It could be even HDFS. So let's talk about why we would even use these things. So you might have like event-driven applications. So left is kind of the, yeah, your left, the traditional kind of transaction applications, and then you have more like this event-driven stuff. So you have an action, you want to record it, you want to adjust it, you want to do something, and then write it somewhere else. We have analytics application. This is probably the most common one because you have tons of data, and a lot of people usually are living in this batch analytics world, and then they're like, ooh, we need to be able to do real-time or near real-time streams. Sometimes this is valid, sometimes it's just all hype. For me, it wasn't hype because in the advertising world where I was using a lot of this, you have to do something called open real-time bidding. So you actually need to be near real-time recomputing what the cost of an ad should be and the impression and click and all that, so people can actually bid against it. And then you have more common is also data pipeline applications. So you're basically just pushing data through these pipelines, either for transformation or manipulation, enrichment, and you're just moving along the data between each of these sections. So obviously with Flink, we can actually just use it for everything. So on the left, you usually have like your transactions or logs or inner things or clicks in my case, and they're going somewhere, and then you're pulling in for other stuff and it's going downstream. So we talked about this a bit already about this data flow. So once these tools come into play, like, you know, one of the first questions I said, big data, and it's like, well, it's subjective. So sorry, I skipped one thing. I'm not 100% on this talk, so it's a newer talk. I want to talk about real life examples actually that could relate to you. So if you're a company that maybe doesn't do crazy huge amounts of data, but you're like, well, this just sounds like fancy magic and I don't need it. It's good for things like, you know, I want to do, there was a company that came to me and asked me, where would this be applicable? And I said, well, if you can have something like every transaction that happens for your customers when they swipe their card and you have a point of sales, well, when you go to a bar and you swipe your card to open up a tab, it would be great if you knew as quickly as possible if that user is a high spender or not, right? So that you could actually tell the waitress, like, you should hit up that person every 5 minutes because typically they tip $20 or they spend $100 on bar or etc. So like there's applicable things as devs when we start looking at where we work, where it's like, wow, this stuff would be really great if we could do in a relatively near real-time kind of fashion. Not just the analytics only kind of, I have a bunch of data and passively I want to compute something. You might be sitting there like, no, there's real money and real value if I could just have it so that something happens and I can quickly figure out some output to notify blah. So when do these tools really come into play is more things like in the past, this was with Samza. So, and the analytics platform I had built was, so they got 2 billion daily ingestion events, and this works out to about 46K a second because I know if you do the math, you're like, this is a lie. That's actually 33K a second, not 46. But with streams, you have to realize you have to cover the current stream as it's happening, plus, so you have the real-time stream plus downtime, because if not, you would end up never catching up to your stream. And then internally in that company, we had something with SLAs. So you basically had to be roughly about 5 times so you could recover for every hour of downtime, you could be caught up in about 15 minutes. So roughly the current scenario I'm looking at for what I'm building looks like this, and the future growth kind of looks like that. So we cover, now the other thing is you have to realize if you're using like pipelines, every step, actually does my mouse show up? Yes, it does. Okay, so every step we have more data moving, therefore we have more events. So you may have ingestion, and you may have validation because maybe you didn't do validation on the client side or the server side, and now you have to do it in your pipeline. And then you could split something like, oh, I have a metric and I have a log, and there's different types, and we do different transformations and different analysis. But if this has, you know, 80 billion coming in, and then you validate, and that's another, like, I don't know, 70 billion here, and then there's 60 billion here, and then, you know, this is a subset of that 60 billion, it starts adding up. You all of a sudden end up with like this pipeline that's like 450 billion events. So data streaming has all these challenges, and it's not something that you should just be like, okay, I hear this talk, it's about data streams, it's about Apache Flink, we should be using Apache Flink everywhere. Because the problem with this is you take on some of these issues. Now, Flink is going to solve a lot of this for us, but it's still consideration. Like if you're not in these kind of scale of like, you know, I don't know, if you're not dealing in like hundreds of millions or billions or, you know, more requests than a single node you have that can serve and things like this, right? If you're just at like, listen, I handle 1,000 HP requests a second, you're probably not going to need to go this far. Like I even remember on Hacker News, someone's like, listen, you can get away with just running like shell scripts chained together and you can get better performance than having all the upfront stuff with Flink, because it's going to do a bunch of upfront containerized, well, not even containers, it's going to do upfront job scheduling and stuff, and there's overhead to that. But once you start hitting larger numbers, this stuff's going to matter. So the challenge is that you're like, well, this sounds really easy. Why don't I just write my own? We get into things called like checkpointing. So imagine you're going through your data stream and all of a sudden I pull the power cord. It's like, where were you in your data stream? How do you restore that? And then there's state, like, let's assume you were doing impressions and you want to keep a counter of the impressions. How many users viewed my website? So 1, 2, 3, 4, 5, 6, 7. I pull the power, you plug it back in. You're like, wait, where was I? Even if you have checkpointing, it knows you're on message 8, but now you don't know what the state was at message 8. The counter should also be 8, right? There's a ton of stuff like, okay, you have 5 jobs or 5 of these jobs running and 1 job dies. Okay, so does the job get restarted? Does the other 4 jobs pick up what that job was doing? And everything's lovely because you get into this distribution where, or distributed systems. So it's like everything's just multiplied, because before you only had 1 box, now you have like hundreds of boxes maybe. Backfilling jobs, for anyone who has lived in a life of like Spark or Samza, especially if you're in something like you want near real time, you will have a stream and there will be some sort of outage. And obviously there's data still happening, right? So when, say, something like Flink restarts, do you start where you were or do you start at the tail end? And you might say, well, I'm an ad platform. I don't care about all the data that happened when it was down right now. What I care about is what's happening right now, because I want the bits to reflect what's happening right this moment. So I'm going to go to the very tail of the stream. But the problem is now you might have billing that goes, actually, I do care about all that data that we just skipped over. So how do you have these jobs backfill? You could have separate jobs, but sometimes you have things where it's like, yeah, but now I want historical stuff. So basically, backfilling in Samza, I'll show you, it's Samza. I'll show you with Flink. It's very easy with Samza. This was a pain in the ass. We basically would write these one-off jobs, and with if statements or case statements, that would be like, we know we stopped at message blah. So the new job is going to start at message X and run until it hits message Y, and then it's going to stop. And you might think, well, that doesn't sound so bad, until someone reverses the if statements. So it's like, you didn't start here, you started all the way at the start and you ended at your starting point, and then you get stuff like duplications. And also, obviously, we want low operation cost. Like, you know, when you start having something that's going to spin up a bunch of stuff for you, it's got to be pretty easy. So talking about this stuff, what is Flink, right? So this is from the docs. It's basically a fancy way of saying Flink is going to abstract a bunch of stuff. It's going to spin up a lot of compute for you, and it's going to hold state for you, and it's just going to make your life easier. That's exactly what the doc says. So, you know, it's obviously battle proven. So there's major companies like Netflix using it as for example. So people have got it up to multiple trillions of events per day. They have terabytes of state maintained, and they're running on thousands of cores and thousands of boxes. And we care about this stuff because the original stuff was like, you don't really want to jump into these tools unless you have a reason. And if you have a reason, all of a sudden you want to make sure that this tool scales. Like, you know, when we're talking about 450 billion events, and you start saying like each one of those events is X bytes, and then you start saying I need to maintain state, and there's going to be 450 billion events, and it's going to run on 500 boxes. It's like, well, I would prefer picking the tool that's already been battle proven and not have to be the company that's like, whoops, I'm the first person to hit the spot where the state just falls over, or checkpointing doesn't work at this point, or we're checkpointing too often, or, you know, I would much rather the larger companies like Stripe here to solve these problems for me. So the nice thing about Flink and why I wouldn't have used Samza again, given the scenario, is because one nice thing is it basically gives you these 3 different layers of how to interact with the frameworking. And for example, like the high level stuff isn't anything really that complex. It's basically you're just writing SQL, right? And we can go one layer deeper where we can start getting more access to things. Now we can start doing windowing. What else is in here? This is, I think, just a word counter in here. Yep. And it counts words over a time window. Like, it's not so much that you actually understand the code itself. It's just showing that, okay, Flink is going to make it either really, really easy, like you're data scientist and you're just like, listen, bro, I don't want to write code. I just want my output. I want you to go over the data stream. I just want to compute something. Give me my answer. So it's like, great, SQL. Or even an analyst, let's say. And then you have someone who's like, I need a little bit more. I want to run some code stuff. I want to invoke some class I have and do something with the data. So great. And then you can get really low level where you're like, I want to tell Flink whether or not to do checkpointing or how to write the state or where to write the state, or basically you just can override whatever you want. Like what you can see is the open is the very start. So you can actually have it so it initializes and just says, I don't want state, right? I'm going to turn off doing state because I want the performance, or, well, in this case you can't, but checkpointing is actually the better case, is you could just turn that off. So we like this because now it's like, great, on a high level, I can interact very, very quickly. On a low level, like I just know what I'm doing, I want to do X, but I don't want to have to like fork the project. It's like, great, here you go. So let's talk about some of the challenges. So for me, it was analytics. Imagine unique visitor detection with 1 billion of page views, right? And you're going over this data stream. It has tons and tons of these page views, and you want to do unique detection. So once again, we have all these problems. So Flink comes in and it's like, I gotcha, no problem. Because I thought about this and I have this beautiful architecture and it just handles everything for us. So basically, you know, it handles everything from the scheduling to splitting up the tasks for you. It does everything in parallel, and it's going to handle retries, and, you know, it's less about you fully understanding the diagram and just seeing like, look, it does a lot for us. Like even things like how the jobs get submitted, making data flow diagrams. It supports Apache Beam. So what you're doing is when you write this, you can transfer it to something else that also supports Apache Beam. So you're not vendor locked to Flink. You know, there's side channels between the different workers so that you can have state go from one worker to another worker. So you can global state. You can have, I want to deploy this task. I want to stop this task. I want to restart the task from a certain checkpoint. I want to trigger the checkpoints like heartbeats. Like it just recovers itself. No problem. Not your worry. It does the checkpointing. Not your problem. And like, this is actually really big things. I know I'm just glossing over because this is stuff that I've just had to face so much. But when you're really going into this world, you're like, no, this is actually really important. Like making sure that I have efficient checkpointings is really critical because, like I said, you have 10, 20, 30, 100, I don't know, 1,000 boxes. Even AWS is going to have an outage. Something's going to go down. Or even better yet, you have spot instances. You have 2 minutes to turn off. That's it. If you fail, yeah, you better hope that your checkpointing works so you resume where you were and not start at the very end, unless you handle like duplication and all this. Because if you do start at the end and you were at message 100, you better handle duplications or you're just doubling all your data. So distribute it, everything kind of gets broken up. It's got these things like task managers and they each have task slots. And when you write your code, it gets broken up into these different task slots and it runs each individual thing. So we'll do the source a map and key by and window. So we'll do window, which is basically over X period of time. It's not always time, it can be by count. So every 20 messages I get, I want to do something. And then it can take all this together and sync it, which is put it downstream. And I actually thought that each thread was by each task slot, but according to this image, it is not that way. So yay, multi-threads. Backfill and outages, great. Look, as much as we're devs and we're all about CLI world and API, which I actually pretty sure you can do this by the API, you can actually do this also by a UI, which helps when you have like someone like, I don't know, not really familiar with this and they're calling you on your vacation and they're like, yo, everything is down. Like shit's just broken, what do I do? And you're like, no problem. You just want to restart the job from the last checkpoint and they're like, click, and they click submit and all the world is saved and yay. The other nice thing with these checkpoints is they're full checkpoints. You can actually move them to another region like in AWS and just restart Flink and everything just works. So you're good to go. Well, yeah. So this is nice if you need full DR on region to region. And this stuff is more like the backfill job where I was saying, like, all it takes is for someone to accidentally mess up in the code. Not so hard to mess up when it's just a UI field. Like you could still mess it up, but it's just less likely. Like I said, I literally had someone on my team go, instead of like greater than, they put less than, and we duplicated all our data. And you're like, oh God, we never planned for this. How do we revert this? Like, and then you're sitting there, you're like, okay, so we have to drop all the data that was in the data stream from whatever the downstream source was, and then restart the job from the beginning. And God pray that no other team have synced from our downstream down to somewhere else, because then we're in big shit because there's no control there. And you're like, yep, okay, well, never want to be in the code writing these one-off jobs ever again. It's very nice when there's UI. So I want to talk about some of the stuff that like just kind of got me when I was living in the world of like this with Samza and or Flink. They're not actually precise to just Samza, but they're things that you're not even probably going to be thinking about unless you really, really live in this world. Some of them will be obvious and it's like, duh, but they're not always. So I had this job that would take 15 minutes to always start up. It was very annoying. It saturates the network actually. And what we found out was that, yeah, remember those data streams we talked about? Well, that's usually where you're also writing your state to. If this is like Kafka, usually there's this thing called log compaction, which compacts the keys and values to the most recent. When you don't have this on, for whatever reason, things get really large. And then when your jobs start up, they're like, oh yeah, bro, I need to restore like 1 terabyte of state. And you're like, yeah, that's why it takes 15 minutes. Preferably you don't want this. I remember when we actually fixed the log compaction in this scenario, across the whole cluster, we freed up like 40 terabytes. So it meant that all of our jobs, anytime they would have to restart, they would just go and like, in this case, they were restoring 372 gigs of state when it's really like 100 megs is all it needs. So this is not something that Flink will solve for us. This is actually something that you need to just be aware of and make sure log compaction is working in Kafka. It's very obvious once I tell you, but this actually went on for 7 months at my company before finally the state got so big that we started saturating the network on these ports and people started complaining that why do the jobs take 15 minutes every time we want to restart? And you start debugging and you realize it was something as silly as like, in the init method, one of the first things we would do is we would write a counter onto like CloudWatch saying the job had started. And we would start the job and for 15 minutes, we wouldn't see this counter. And we're like, wait, huh? And you're like, okay, what's the parent method do in the init? And like, then first line, it's like restore state. And you're like, click. And you're like, what's this do? How's it restore state? You're reading. And you're like, okay, let's go look at what these topics are. And you're like, why are these topics so large? Because you're like, we're not storing that much in the state. We're storing like counters, like unique visitors. How is this 372 gigs? It's supposed to be just an int. Yeah, well, log compaction gets turned off on Kafka by mistake. And instead of it just being like the present state of things, it was the history of the state since like the beginning of time. So stuff like this adds up. Other things that we had was like Upstream max egress. Yeah, this was pretty easy. We just upgraded it. you get into a land of like noisy neighbors. So originally when I had this cluster and all this, you realize that these giant spikes aren't that nice, because you're, in the case it was all real time. So unpredictability like this is not what you want. And we realized very quickly, like, just don't mix the real time with the non-real time. This was just some data scientist, like, I don't even remember what it was, like HDFS, like batch cluster. They would just do stuff randomly every 15 minutes where it was like, go get me like 100 PB of ad impression data or something. So eventually we just split these up and things went back to normal and we were nice and happy. But you don't think about this stuff unless you're living in this kind of world. So one of the things that you start realizing when you're like, wow, you're like, Flink just does all this parallel stuff on different jobs for me and it just lets me run all this computation across many nodes. This sounds wonderful. Well, the moment you have one issue, you don't have one issue, you have n issues. You have those issues on every single other box. Because what happens is if this job restarts to any other box, you will also saturate the network there. So you have basically two options. Reduce whatever it's doing on the network, which we couldn't. This was Upstream from us was just providing us with more than 1 gigabit. So you have to just upgrade the entire cluster. And the reason why is because right now, let's call it box 1 is maxed, but box 1 could have that job just crash and Flink will go, no problem, I'll move it to box 2. Yeah, but you just moved the same problem to just a different box. Now all of a sudden you have to upgrade the entire cluster. And ops teams don't like you when you do this because they're like, yo, you're only saturating one box. Why do you want me to go upgrade like 200 boxes? And this was physical infrastructure at this place. So it wasn't just as easy as AWS, just like click, click, done, no problem. New instance type just deployed. Downstream connection. So you're like, great, Flink, I'll just spin up more jobs and you'll just do more things. And then you realize, well, if you have something like async calls or database calls downstream from you that you're like, or even in your jobs, you're like, every time I get a message, I want to connect it to the DB to confirm something, or even Redis, and all of a sudden you realize, well, wait, those are just going to open up more connections and that thing's just going to die. In this case, it was like a giant MySQL database that we just end up killing. And then we stopped the job. And then we realized that some different teams. So we stop our job because someone's complaining. And then like later we're like, no, that doesn't seem to be the problem. Let's restart it. Oh my God, that is the problem. And then we stopped it. And then we just implemented pooling and stuff like this. So yeah, it's just, yeah, pool or less connections. Performance, you don't actually realize how slow things are until you live in this world of like massive streams and data going through. The network is extremely slow actually. Like if we look at the scaled, it's like, so I want to go round trip within the same data centers like 10 days. Like, holy, that's slow. Even just reading off disk, even though we all bash disk, it's like we're better to do that. And even better if we can just stay in memory. And like you start thinking about scenarios where you're like, yeah, but bro, I need to connect it to my Redis. It's central, it's dope. Because it was literally our scenario. It's like, well, round trip data center, 10 days plus 4 minutes. And you're like, or remote calls are slow. Why don't we just move it local? So there's this beautiful thing called RocksDB, which is the easiest way, and I'm glossing over so many details, and people who actually use this are probably like dying inside when I say it. Think of it as Redis that you run locally and it can spill to disk. Is like the too long, didn't want to read any of the docs. We also had things like this is like, okay, so yeah, sorry, these slides, I put these ones in at the last minute. You have things where if you can't have something stopping in your pipeline, you have a problem. Because let's say that you have 3 components, right? Component 1, component 2, component 3. And component 1 sends data to component 2. And component 2, in this case, let's say, writes it to Redis. and component 2 can't talk to component 3. Well, now what happens is component 1 just keeps sending things to component 2, and component 2 never flushes because it can't put any data down to component 3 or data pipeline 1, 2, 3, whatever you want to call them. So you basically have to either stop ingestion or spill to disk. And in our case, we just said, okay, we're willing to just use RocksDB and just have everything local, and we'll just spill to disk, and we'll take the performance hit on. It's better to take the performance hit of spilling to disk and reading from the SSD than it is for us to have Redis out of memory, which is like the worst thing you ever want to deal with, because it just goes in a state that's unusable. Like these weird up and down spikes was things like we had grown the memory so high that when it tried to do the backup, it wasn't able to do the backup of Redis, and that would crash, and you get in this weird state where you can't even start Redis. So you delete the backup, you go to restart Redis, and then it starts, but then your ingestion immediately fills Redis again, and you get in this weird cycle of like, oh God, this is terrible. So then we had jobs that like would stop ingestion and wait until the downstream from this Redis flush stuff was up, and then we were able to recover. Oh yeah, memory usage. Oh yeah, sorry. So the memory usage stuff is basically like, we can just move here. I had a scenario where you're dealing with all these impressions and you have like billions of visitors and you want to do unique detection. Well, you're not going to just always be able to fit it on one box. But you need to have a central aggregation spot at some point because you need unique detection. So you can't just continually spread it across multiple boxes. You have to have some central authority at some point that's going to be like, yes, that is truly a unique visitor. So you start visiting things like data structures, TLR, DR, like too long didn't read. Just look at Bloom filters. They're super dope. They solve a lot of these problems. You trade SAT, which is space, accuracy, and time. You trade your accuracy to get space and time efficiency. So that was it. So yeah, I have questions. I know I glossed over Flink. It was just like, Flink is just dope, use it. No. It was more so like less about Flink because it's like you really have to read the docs to fully understand everything it's doing for you, and trying to fit in 30 minutes is hard. It's in the scenario where it's like, okay, it's going to handle scheduling for you. It's going to handle re-kicking out the jobs. You're going to get parallelism. Like there's native Kubernetes support in it now in the recent release. So there's your lower OpEx. At that point, it's like, you really need to ask yourself, are you going to take on the complexity of writing this processing framework? Is it worth it? And if so, I'm personally a fan of Flink because their entire approach from day one is they solve the unbounded scenario, and Spark is all about these mini batches. But if you read the SIPs, the Spark Improvement Plan, I guess it's called, they're moving more and more towards looking at solving the unbounded problems. And Flink just says that bounded problems are just a subset, special case of unbounded. And Samza was a great tool, but it just wasn't up to par to some of the problems we hit, like the backfilling stuff, or the community is just putting way more effort into this, or they don't support Apache Beam, which means if I write Samza jobs, I can't move them anywhere else. I'm stuck with Samza. I just locked myself to software. With Apache Beam, you write the job once, so you can move it to anyone else who supports Apache Beam. So if tomorrow Spark's like, I support that, great. If Spark has a new feature and Flink dies, I just go, all right, moving my stuff. So yeah, that's it. Yep. Yes. Yeah, so the question was basically, if you have a job here and it dies and it moves somewhere else, what do we do to mitigate this? In this case, it was literally just upgrade the entire cluster. Well, I mean, or decrease network. Like in this case, it was actually because Kafka, which was upstream of us, or I guess it depends on which way you're really looking at it. But Kafka was giving us the data, and Kafka had more than 1 gigabit of data coming in. So either I'd have to go further than that and find a way to reduce the data coming into Kafka, or I guess compression, LZ4 or Snappy or something like this to reduce the network. Or if it's just sheer volume, yeah, we've just saturated the network, so we don't got much option. And you could say, well, you could partition the data to make the data smaller, which would buy you more time. But in our case, it was because this was like 2 or 3 years ago before Pulsar was big and before I had any exposure to Pulsar. And for those who don't know, Pulsar is like Kafka, just has a bunch of newer features and lets you do fancier stuff. With Kafka, we didn't want to do a rebalancement to change the partition count from, let's say, 30 to 40 or 30 to 80. So we were stuck in a scenario of if we can't make the data smaller chunks for each job, then we're stuck in a scenario where we just ended up upgrading the whole cluster. So unless there's some other magic that I don't know of, but yeah, that's how we approached it. Was just, you just realize that your jobs can move to any other spot. And if you saturate at that spot, you basically, for us, it was reduce or just increase. So, yep. Okay, so this will just be, so in the Samza world, yes, it was just one huge ass Samza cluster on Hadoop, and that was, it was just, for the Flink stuff, it probably still will be. Now you could get into questions like why, and I guess you get into resource quota and making sure that no one just consumes the entire cluster, but I'm pretty sure that Flink has that built in. And there's resilience, like, do I really want everything to just be in one cluster? But for us, or for me, it would be like, I'll run one cluster, but have it just be able to just snapshot and move it somewhere else if we had to. So that would be my like, oh, something bad happened and we have to restore in a different region. Okay. The other scenarios, or I could ask you, where were you going with it, I guess? Yeah, okay. So yeah, you would have a, yeah. So yeah, the question was, or I guess the answer more so was, separate clusters or more clusters would allow you to have a subset of boxes that you would just upgrade, which is totally valid. There's a whole other scenario right there. More questions or no? Okay. Yeah. It wasn't that bad. Like, I don't even know, I didn't put it in here, but it was actually a relatively small cluster to do this. Like, I think the total was like 25 boxes. And it was more about the operations team having to spend the time and go, because it was physical environment. And this was a whole other reason and all this. And we had already bought a bunch of boxes and it wasn't a tiny, like, I don't say that like, you know, just on the side, like, oh yeah, you should run physical, and everyone here is like, haha, cloud has won. But when you've already bought 1,500 servers and you're already running one of like the 25th largest sites in the world, you're like, I'm already committed. Like, it's kind of hard to just tomorrow switch over to the cloud if I've already spent all that money and already paid for it, and it's already there. So wait, sorry, I didn't answer the question. Oh, it was probably something like, I don't know, like 10 grand or something like this, probably. Not even, maybe. It was more like the operation team just hating us. Because in this case, it was, we wanted to do it without any downtime, so by one, and then you get in scenarios where they did it so that they would add the new network card in with the existing old one, so that everything could still talk on the same switch and everything like this, and they just had a separate switch for this because the switch had to be upgraded too. So yeah, they weren't too happy about this, but it was basically like, yo, we need it. Because even in the smaller subset, like, if we max out like the higher capacity thing, or we would have to create a higher capacity cluster, they would still be doing it. It would just be easier because they would just be like, great, we don't have to do this rolling restart. We just literally make a new cluster and you just stop your job and you take a snapshot and you deploy it over there and that's it. But it wouldn't, we would still be stuck with the cost itself. It would just save them time. So I have a backup slot presentation because there's Tamer didn't show up maybe. The other organizer had some issues today. So he lost like his phone. He told me maybe he wouldn't be here. I don't know, but yeah, it was complicated. So I have this, well, I guess we can stop briefly and get pizza and more drinks.